Good afternoon. My name is Brian Benz. I am a cloud developer advocate at Microsoft, and
I'm Priyanka. I'm the open source lead at Lightstep.
And we're here to talk to you today about perfecting reliable code delivery for the cloud with JBoss, Spring, and OpenTracing. So we've got a bunch of different demos we're going to show you, and just a few slides. And I'll kick things off, and then we'll pass it over to Priyanka. So, first thing I want to talk to you about, we're going to basically cover Java web apps in the cloud. I'm going to talk a little bit about CI/CD, and then Priyanka's going to cover OpenTracing, and then we're going to cover some more resources. But mostly we're going to show you some demos of things running in VMs that we set up. And we've got a cool little interactive thing later we'll ask you to help us with. I'm going to talk a little bit about Azure VMs. How many people here have been working with Microsoft Azure at all? Just one of you? Okay. So we actually have, people are not necessarily aware of this, but about 40% of our virtual machines on Azure are Linux, including Red Hat Linux. We've had a partnership with them since 2015. Before that, we had an unofficial partnership with them. We actually are not just the Windows.NET cloud. A lot of people outside of the Microsoft world are surprised to hear that. But we have different ways to get started with VMs. We have marketplace images, and those are, I can show you that here. This is my dashboard that I use every day for Azure. And if I go here and I type Red Hat, there's actually several Red Hat images that we have, Enterprise Linux. These are ready-to-go images. You can bring your own license. Red Hat OpenShift container. Those of you who may have heard of the announcement we made day before yesterday about our partnership. We have a fully supported Red Hat OpenShift container platform on Azure now, but a ton of resources here, both officially from Red Hat and third-party that you can use for Azure. We also have community images. Some of those images that I showed you down at the bottom there were produced by Bitnami and other third parties. They run on Red Hat Linux, but they're not necessarily Red Hat Linux. And we also have, you can actually bring your own image as well. I'm going to talk a little bit about how you would do that later. The other thing we have is provisioning. So today I'm going to show you setting up a Ubuntu VM with Wildfly and then putting a Spring Boot application on top of that. And it would work just as well with JBoss EAP. I just used the completely free version so that everybody has access to this independently of any licensing requirements. To get that out there, we have the portal that I showed you before. This is my portal. This is an OpenTracing demo. Whoops. I don't know what happened there. Ew. Oh, great. Not connected to the Wi-Fi again. I had a little problem with this earlier. I'm not sure what's happening. Is it? It's kicking them off the Wi-Fi? Okay. Well, not that I like it, but I don't feel so bad now. Thanks. Yeah, that's weird. Anyway, I wanted to show you in the portal. It's taking a while to connect. I wanted to show you the image that we have in the portal, but maybe I'll just skip over that part. We have an image in the portal. I was going to show you the graph that shows the activity on it and things like that. It's pretty basic stuff. We also have a CLI. So we actually have an Azure CLI that runs, it's a command line interface you can download. It works on Mac, Linux, and Windows. And you have access to all the Azure resources and services that we've built. Let's see how the Wi-Fi is doing here. Ah, good, okay. So here's the VM that I wanted to show you. And we also, you can obviously use this in the Windows command line. We also have Bash on Windows, so this is fully compatible with Unix. If you have any Unix/Linux commands that you want to use, everything is built into Azure. And I'm glad the Wi-Fi is back up. This is the VM that we're going to be showing you today. Just some activity running on there. But I also want to show you this very cool thing. If you don't want to download onto your machine the CLI, you can actually fire up a container instance here. I just hit this little icon in the portal, and it sets up a Docker container with the CLI built into it. It also has the Cloud Foundry CLI, a few other CLIs already pre-made and built, and we maintain those and keep them up to date. So it's kind of cool. You've got a CLI built into that. There's even a phone app that has a CLI built into it. So you can provision VMs and networks. I've done it before just for fun. I actually provisioned VMs from an airplane on my phone in, I think it was Tokyo. So a bunch of different locations we have all over the world. I was able to do that here. So here's my actual CLI ready to go. So what can you do with that CLI? Let me show you. This is our open source code editor. It's free and open source. It's called Visual Studio Code. How many people have heard of that before? Okay, a few of you, cool. So for those of you in the back, hopefully you can see this. This is, can you see it back there? The screen? Okay, cool. This is what I did to provision this demo that I'm going to show you. Let me show you the demo first, just so you know what I'm talking about. It's on Wildfly. It's a Spring Music app. It's a basic Spring application that a lot of people use. What I've done is I've cloned it and made a few changes so it works with OpenTracing, which we're going to talk about a little bit later. But basically, it's just an app that displays 500 albums. And I went out to Kaggle. How many people have heard of Kaggle.com? Just one of you? Okay. So Kaggle's kind of a cool resource where you can get a whole bunch of different data sources to play around with. They're all free. I downloaded Rolling Stone's 500 greatest albums of all time and put it on the Spring Music app. So you've got them here. You can sort them by title and artist and year. And if you notice, it took a little bit of time to load, and that's cool because I'm going to show you OpenTracing later. And the OpenTracing dashboard actually shows you the activity and how long different pieces of this application are taking to run and where you can maybe improve it. And we're also going to show you Lightstep in a bit as well, which is a third-party application built on top of OpenTracing that gives you a little more information than a basic open source solution would. Let's see. So this is the actual running demo. So how did we get here? On GitHub, GitHub, BBen, Spring Music, Lightstep, the application and all the details that I'm going to have here, including the script, are out there. I mentioned the Azure CLI. So the first thing I do, I'm going to skip over this part where we create Cosmos DB. That's a backend database that we use. It's a pretty cool one if you want to look into it. But we create the backend database, and then we, from the Windows command line, if you want to actually build this application just from Java, it's a Gradle application. So you say Gradle w clean assemble, and it runs. You can hit it with localhost, but I'm not doing that. I'm going to create a VM, and I'm going to put that out there. So the VM for Azure, the CLI command is aazvm create, and the name of the actual VM that you're creating. The location, we have more than 50 locations all over the world that you can actually implement these in. We use the latest Ubuntu image, and we said authentication type password. You can also use SSH and generate your own SSH keys. And then the username, and then the password I don't display, obviously. So that's what I had to do to create the VM. It takes a couple of minutes. Then I have to open some ports. I opened a couple of ports on the VM just using the azvm open port command. Now, I decided to go with Nginx for this particular solution. So Wildfly is actually running as a service on an Ubuntu VM, and then Nginx is actually controlling the outer activity via reverse proxy. And the reason why I did that is if I want to run this on, if I want to actually run just Wildfly by itself on a VM, I have to open all these ports, 9993, 809, blah, blah, blah. So all those ports had to be opened and running because it has to bind to the local IP address. Instead, I used Nginx as a reverse proxy, and then everything runs off localhost internally on the actual VM. And I'll show you why I did that in a minute. The next thing I do, and then we created a demo separate VM for Jaeger to run Jaeger. It's actually compiling all the results that we're using for OpenTracing, and I'll show you that in a sec. Next thing I do, SSH directly into the VM. So I'm doing all this from the command line. all I had to do was download the CLI, and you can use this on Mac, Linux, or Windows if you're using Ubuntu or Ubuntu add-on. Next thing I do is an update. I add OpenJDK because we actually want to compile and run the application on the VM. Otherwise, you could just build a WAR file and deploy the WAR file out to Wildfly. But we actually want to build it on the VM and then allow the VM to actually deploy it. So next thing I do is I set up Nginx. So apt-get install Nginx, pretty easy on Ubuntu. And then I have to go in Vi, and I have to change one little setting in there. Then I have to go in and enable Nginx as a service. So the next time that my VM starts, Nginx will start along with the VM. Then I go in and I set up a Wildfly configuration file. In this case, I'm going to use standalone XML, which is basically, it's running as a local service on this VM in Ubuntu. There's a script that you set up to actually run Wildfly. There's the actual location of the Wildfly binaries. And then you make the script executable. Next thing you do, set up the Wildfly service. There's an application server. There's a bunch of settings here that you have to do to set up Wildfly. Then you set up, you enable the systemd, actually enable Wildfly to run as a service when you fire up Nginx. So the next time I reboot this VM, Nginx starts, Wildfly service starts, and my application starts. So I don't have to worry about, did my service go down, did anything go down? It's sort of a way to actually manage this automatically, so it runs automatically when you do this. The nice thing about this is I'm going to package all this up. If you remember before, I could say you can bring your own VMs. I'm going to package this up as a VHD, and then I can deploy it anywhere I want, including to what we call a VM scale set. And I'll talk about what that is in a minute. So next thing I do, create a symbolic link between Nginx and Wildfly. So we know they have to start, and then I restart the Nginx service, which by proxy restarts the Wildfly service. Now let's actually get some code on there. So we're still in the VM. We clone the Git repo from GitHub with all the information in it for Spring Music Lightstep repo. And then we do the Gradle clean assemble. In this case, you can run it locally just by saying Java jar Spring Music and change that to WAR file. And then you can access it via the IP address right here. The Wildfly install, let's see here. Oh yeah, okay, so there's a little bit out of order here, but I did actually download the Wildfly and set it up after that. So Wildfly set up by wget. You just basically unzip it, put it in a folder, and then set up the execution permission for Wildfly. You have to add a user, so you add the user here. And then the next thing you do is change the localhost bindings, so you actually change them to the local machine. What else happened here? Let's see. You're still in the VM. And then I basically generate a WAR file. To do that, there's a Gradle setting that you set that basically tells this. Let me see here. Build Gradle. There it is. All right, open build Gradle there. It actually compiles and deploys this, but where's the WAR command? It's right up here near the top. There it is. If I want to create a jar file, I just comment out that. It's going to generate a jar file. If I uncomment it, it creates a WAR file. The WAR file is what you need to run on a G2EE application server versus a jar. So the WAR file actually compiles a whole bunch of stuff, and then you deploy that out to the Wildfly WAR deployment. All right. So the next thing you do, I take that using the move command, and I just move it to opt Wildfly standalone deployments. And then Wildfly recognizes any WAR files that you drop into that directory and fires up the service and gets it running. And that's what you see here. So this is Wildfly running this app. Drop the WAR file in there. It did it again. Man. Okay. Anyway, I shouldn't have tried to refresh that page. But let me show you this while we're connecting to the Wi-Fi. This is Jaeger. So we have two VMs. One is running the Lightstep application, the Spring Music application, and when I refresh it, it actually generates all this information here. Now, what I'm looking at here is an OpenTracing visualization, okay? Everything down here on the lower end is, you see the duration of the actual process is here. The actual timeline that the process is running is here. And we're still not connected to the Wi-Fi. What the heck? But that's okay. I can still show you this. I'm not going to refresh the screen. I was going to refresh it, and you'll see the latest. But we won't do that right now. The larger diameter of these spots means depth. And depth means how long it takes for this process to handshake to another process. The smaller ones are span. So span means, and Priyanka can probably explain this better than I can, span means how long that process takes to run. So there's two different activities here. Process running and then passing the information / details to another process to run. That's called depth. How long does that take to pass? The span is just how long does the process take to run. So that's what you're seeing here. I'm still not connected to the Wi-Fi. Anyway, that's okay. So you get an idea of what it works like with Jaeger. That's basically what you have. Next thing I want to talk to you about is you can actually deploy this using a container as well. And this is the Docker file that we have in Wildfly. You can run this locally, or you can run it on a Docker engine that's on the server as well. And there is actually, if you go out to the Docker hub, JBoss Wildfly has a template that you can use for this. I'm so glad I loaded my tabs before we started this presentation, by the way. Because this is bad. It keeps kicking me out. So this is the basic one, and I've modified a few things in this Docker file so that it runs on a VM versus a local machine. In this case, added the IP address and exposed 8080 so that it's actually going to hit it. So when I actually hit the VM from, I use the IP address with 8080, it'll actually load that application for you. The last thing I want to show you, I want to talk a little bit about CI/CD, and hopefully, so I covered that. I talked about the CLI. I showed you the demo. Oh, so VM scale sets. That's the other thing I want to talk about. So the what can you do with this VM once you have it running? It's just one VM, right? We also in Azure have these things called VM scale sets. So you can create what's called a VHD file from that VM. So now that I've got the VM exactly the way I want it, Wildfly fires up when I start up the VM, and also Nginx is working as a reverse proxy. Nginx is great at scaling that out. You can set up a VM scale set, and here's a command using the Azure CLI to create 1,000 VMs. Not that you'd want to necessarily do that all at once, but you could create 1,000 VMs. This one uses an image called Ubuntu LTS, which is an image we have stored on blob storage somewhere, which is the latest Ubuntu VM. But you could replace this image with your image name. It could be in any blob. It could be anywhere that's locally accessible via URI. And that will actually take that image and deploy it 1,000 times to different scale sets. And if you have Nginx configured correctly, and or some tools that we have on Azure to do that, that would actually build a scalable system with 1,000 VMs. You don't have to generate 1,000 VMs. We actually have rules for this as well. So if your VM CPU is going over a certain limit, you can add another VM or another 10 VMs. If it goes below a certain limit, you can scale those back to save money. So that's another option as well. And I mentioned the container technologies. We have AKS. We have a native Kubernetes service. and Azure Container Instance as well. And we have SDKs and services for Java for all the services we have on the back end. So if you want to use a MySQL backend or a MongoDB backend or Azure Active Directory or SQL, we have those services there, and you can access them through Java as well. Just a small change to actually add those in. And last but not least, just want to show you on Jenkins. Let's see here. Where is that one? Well, you know, my Wi-Fi is, oh, it's connected again. So on Jenkins, I just want to show you one thing that you can do with Azure, which is kind of cool. Jenkins, people don't know this, Jenkins actually uses Azure to build Jenkins. And this is an infrastructure that they use to do that. We have a ton of plugins that we built for Jenkins that you can use. The demo that I showed you was a VM, but you can create VM images and container images, store them in Jenkins via plugins, and have those fire up, run tests, run deployments, et cetera, et cetera. And I think I'm out of time. I'm going to pass it over to Priyanka for the rest. But check out those Jenkins plugins as well. If you go to the Jenkins plugins directory, there's probably about 30 plugins that we built in conjunction with Jenkins to actually do this. And that's what you see here. If you go to ci.jenkins.io, this is actually Jenkins testing pull requests and other things before they deploy the latest version. And there's a bunch of different Ubuntu images here, a bunch of Windows images, and a bunch of container images all running tests all at the same time. And without further ado, I'll pass it over to Priyanka to talk about OpenTracing and the offerings that they have through her company, Lightstep.
Thank you.
Yeah.
Can everybody hear me okay? Awesome. Bear with me as I, do all this.
Oh, sorry.
Oh, is that yours?
Yeah. Thank you.
Okay. Oh, no. Slideshow. Unclear what's happening here. Mm-hmm. Okay. All right. Cool. Well, as Brian said, I'm Priyanka, and I work on the OpenTracing project, which is part of the Cloud Native Computing Foundation. Today, Brian told you how to get started with VMs, with Azure, and then do CI/CD. If you are interested in that, it's highly likely that your system is quite getting distributed, if it isn't already, quite so. And while there are lots of positives of working with microservices or functions as a service, there's also a lot of pain points that come up particularly on how you operate your system and the operations of each service. One of the big challenges is observability through a distributed system. So as is evident to most of us here, software is changing. People used to build more with monoliths, and then slowly pieces of those are being shaved away and becoming services or microservices. Sometimes people tell me, oh, we only have monoliths. We have 20 of those. And it's like, oh, so those are 20 very large services. OK. So how many people here are building microservices or services? Okay, a bunch of you. So you guys probably feel the pain a lot more than anyone else. So you've probably seen this, that with services, you're able to ship faster. You have control over your domain, but there's also new complexity when it comes to interacting with other services, and there's a lot more data for you to see. And when it comes to understanding the path of a request or a transaction through your system, it used to be a clear thing going through one box in a monolith, and now there are these various pieces that are talking to each other. It's a little hard to tell where the request went through. So systems are also getting concurrent now. So this is the simple and efficient thing of like a process going through one thing happens, then another, right? And then a little bit concurrency was added, and now then comes async concurrency, which is just a lot of processes start at different times, and many of them are happening at the same time, and your request, the critical path of that request, which are the blocker transactions as this goes through, is unclear. At this point, we're at distributed concurrency. And so how do you understand distributed concurrent systems and then tell the stories that you need to understand what's happening? So this is where distributed tracing can help. How many people here are familiar with this concept? Okay, a few. That's awesome. More than I usually get, so great work. So distributed tracing is really just following the life cycle of a request as it goes through your system. So if I open my phone and tap something, that's the beginning of a request on the client side, and then it talks to the server API, et cetera, and then like goes in through all the various parts and comes back out. That's the whole process. And that's what you can map with distributed tracing. Here you see kind of like an example, simple transaction, and the various pieces it goes through and then comes back out. So being able to follow that is what a trace is supposed to do for you. So let's get into what really a trace is. So traces are made up of spans, which Brian alluded to. You can think of a span as basically a structured log. There's a start and a stop, and the span can also contain more information. It can be decorated with, tags, logs, whatever information you want to add to it. And if you put together a bunch of spans that show you the whole path of the request, that's a trace. So it's like a tree. Here you'll see, like parent, these words over here. So I'll just quickly explain a little bit. Parent span is basically the starting point of the request. And the child spans are stuff that happens underneath that larger span. And then you see the span context baggage dotted line. So that looks very innocuous, but it's actually a very critical piece of distributed tracing, because if you have a process happen here and then it goes through to the next thing, but if you cannot connect those dots and know this is actually the same request, you've lost most of the value of distributed tracing. So that's a critical piece. If you do get all of that correct, then you have a lot of value from distributed tracing. It can help you understand anomalies and outliers in your distributed system, and you can quickly root cause the issue because you know exactly what's happening. If you map your whole system with it, you have full observability and kind of like a system map. If you're running CI/CD, you can understand why builds are slow, what resources are being utilized, things like that. And in the same process, you can do gradual software rollouts where you get full transaction data of each phase and track performance of the rollout. Now, this is what distributed tracing offers. Let me clarify that that's not what OpenTracing does. We'll get to what OpenTracing does in a second, but I wanted to throw that out there to keep it in your minds as we go through this. So this is an example of a request with the visualization of a trace. So my right, your left. Your left is like a very simple system shown here, and like a path, like something starts in the client, web server, there's authorization, billing, and talks to the database. And on the other side, you'll see that put in the context of time. So it's the first thing that started here is the client request, right? And then it talked to the web server, which started a little bit after, which makes sense. Pretty concurrently, authorization was started. And then after it was done, we did the billing, which is when we verified the zip code, processed it, and then the call went to the database, and then that's the end of the trace. So it just puts the context of what's going on and at what point for you. So that's all very great. Tracing can be useful. So then why isn't it ubiquitous? It's not ubiquitous because the instrumentation needed to get all that information out of your system can be very, very painful. And up until recently, it was too daunting for most people to pursue. The major issues that people faced is that often if you were doing all this instrumentation, it was connected to a specific vendor. But if you do all this work, you want to be able to try different things to see what really works for you. But everything was very custom. Then the other issue is a lot of systems would offer this automated tracing and all that. And the fact is that if it's a really complex system and specific developers are dealing with specific problems, they know the most about it, and they know where to instrument to get the most bang for buck, so to speak. And doing it automatically is too hard. The other, and the last two are really big ones, which is that these days it's not like an application is built just in Java, just in Golang, or just in whatever, right? We're all running polyglot systems. Actually, how many of you have more than one language in the system that you run in production? All of you. Exactly, each of you. So if you really want to understand your system, you have to know what's happening across those various platforms. Otherwise, you're only getting a small slice of what's happening. So that was an issue. And then finally, kind of similar is if you have a lot of open source projects, frameworks, libraries in your code, if they all have different ways to trace and understand the system, it's going to be not that useful, again, for that same reason, which is that you get a piece of information about a section of your code, not the whole of it. How many of you use open source in your production systems? Again, all of you. So these are very relevant issues to you, as I'm sure you already know. So this is where enter OpenTracing, which is your ticket to omniscience. So OpenTracing is a vendor-neutral standard that enables you to set up the semantics of how you will gather the data from your system and then pull out with a tracing system. So OpenTracing is just the API, it's just the spec, tells you how to set it up, and then you use a tracing system to then get information out and analyze that data. So OpenTracing does no analysis, it's a no-op effectively. So the OpenTracing API has been built by a bunch of leaders in this space. Tracing has been around since the 70s, but one of the first commercial implementations was Dapper at Google. And they wrote a paper about it, which became the source of a lot of people starting tracing systems in their companies. Zipkin came from that. Jaeger's influenced by that, which Brian showed you. And all these folks got together and then together built the OpenTracing API in 2016. So if you think about what's the OpenTracing architecture, how does this really help? So if imagine this is a microservice process. There's the OpenTracing API, which talks to your application logic, the frameworks, packages, libraries, other stuff that's going on there. They all connect to OpenTracing. And then just through a main function change, you can access any of the tracers that support it. This is a small list. It's by no means complete. But like Zipkin, Lightstep, Jaeger, et cetera, all these are options that you could just plug and play and try out once you've built an OpenTracing based instrumentation in your system. There's a lot of companies that have been using it in production. This is not a complete list. This is just some folks. And you'll see everything from small startups to traditional enterprise all in here because this is a common problem and a growing problem. And this, arguably, I think, is a much more important slide to see because hundreds of projects in open source are instrumented already with OpenTracing. So that means you don't have to do anything. And you will just import a library, and then you'll get all the benefits directly. In fact, the demo that I'm going to show you is going to show exactly how easy it can be. There's tons of tracers that support this API, and officially it's 9 languages supported. There's so many edge case projects happening that I cannot be oh, I 100% know it's 9 languages or it's 13 or 15, but 9 for sure. So this is a bit, this shows you a bit of the scope of that project and how every day its scope increases across the software that's out there. So it's every day that you use OpenTracing, the more you'll get out of it. Gift that keeps on giving. So that's all great stuff to say. How about we look at it in action? So what we're going to do is we're going to go to the same app that Brian showed you. We're going to go and play with it and see traces. So if you guys can pull out your phones and go to this URL, aka.ms/music tracing. And if you want, you can use the QR code. It'll take you there as well. And once you do that, you'll see something like this on the mobile screen. Now, before we start doing things, let me just, oh, I'm so sorry. I'm actually going to get my phone to do some tapping and stuff, too. Where did I put my phone? Great, I've lost my phone. Give up. This is a common problem. Every 5 minutes, I lose my phone. Are people good? OK, I'll just wait.
I'll do this as well.
Thank you.
So what we're going to do is add albums to that application that we saw, and you'll see the actual activity that everybody's doing on the application, and then we'll show you what it looks like through the interface on OpenTracing. Is the Wi-Fi? Oh, again.
Bummer. OK, well.
We have slide backup.
Oh, we could
selected.
turn off the Wi-Fi and then the phones would work. Okay, great. Thank you. Okay, please try to add an album. If you start with the album with an A or a number, it's going to be easier to find it. If it's funny, that's bonus points. So, okay, so it'll look something like this. And before we see traces, let me just quickly talk through the architecture of this very complex application. So it's a Spring Main app which has Postgres, and it's built with OpenTracing bindings for Spring and Java Web Servlet JDBC. So those, I did not do anything to make, to get them to be OpenTracing compliant. They were already there for me, just to use as I needed. And this is kind of what the flow looks like. So, and as I was saying, I didn't have to do anything. So here you see, like, I'm importing the OpenTracing libraries, but I also got, and that's where I have Spring Cloud Starter. And what that does is, because this is in there, the job of this thing is to check what other projects are being used in this code, and if they're instrumented with OpenTracing, it'll automatically pull all that info.
I'll just add one little thing. So for those of you familiar with Spring, they have these things called annotations, and the annotations are picked up by OpenTracing automatically when you add that Spring Cloud Starter in there. So we didn't have to change the code at all to track every single process in the code. Yeah.
All I had to do was import this library. So I did that, and now I hope if somebody got a chance to go through, that would be great. If not, no worries. I am going into, yeah? Okay, great. I'm going to go to, sorry. Here's the app. I'm going to just refresh it. Oh, thank God, it's fine. Okay, and so if we sort by title, does anybody see theirs? I don't know which ones you guys chose, but there's some options here. And what happens while you did all of that is, this is a tracing system that's using OpenTracing called Lightstep, which is where I happen to work. And this is a live view of all the transactions that have been happening. And so you see here 1335, which is just now when you guys created an album. I added a span, operation called client add album for me to know whenever somebody adds something. And I see here this example, it has 3 spans. And if I want, I can see other stuff that's going on as well. But if I want, I'm just going to do service filter Spring Music. I'm going to operation filter client add album, because those are the most interesting traces. So I see a bunch here. So I'm going to just, I'm just going to pick this one and see what does this trace look like. So this is really interesting. Here is the trace view, which, as I told you, is like a tree of various spans, which are just start and stop times. So the first operation is client add album, which is the front end piece of it, the client side. And you'll see a thick yellow line going through that. That shows the critical path, or what are the blocker transactions, processes that are going on. And you see it's yellow mostly until here, towards the very end, where we see Java Web Servlet takes over, and then after that it's the JDBC. So, and on the right side, you see all these tags which give you more information of what's happening. Now, keep in mind, I did none of this work myself. It all came in because I imported the right library, and it was auto-instrumented for me. Excuse me. What this tells me is that both the servlet and the JDBC are very well optimized. The JDBC is Postgres and is anyways good. And most of the time is being spent actually in the client. So if I want this app to be more effective or be faster, this is where I need to spend most of my time. Now, knowing the application a little bit, I know that it refetches all the albums when you do anything, and that makes sense why this critical path is so long here. And if I wanted this to go faster, I would just fix that. I don't need to go anywhere else. If I do optimize the servlet or JDBC client more, I'm not going to get that much return on investment. And this is what this trace quickly told us. If we had a lot of, yes? Oh, yeah, it's just giving itself some time in case something else comes in, but I know it's those 3. So if we look at this is, when it's all done, this is an example that I had pulled before, so nothing much changed really, it was just checking. So if we had a ton of transactions happen here. We could go into this dashboard that I've made. Oh, actually, we still do see a lot of this stuff here. This is great. I'm going to make it last 1 hour. And, oh, that got worse. Just do 12 hours. You see like these spikes here, and these are all you guys going in and like trying out things. And what's nice about this, and this is where this goes from just tracing into real analysis. So if I go into this dashboard, this is actually a time series view, and I can, what happens is that these spikes, if you see here, it shows me that, can people see? These spikes, they show me that, okay, this particular transaction took 1 second, which is really long, right? And it is a P97.7, which means it's really up there. It's like high percentile of the latency options. Like it's like one of the worst. And so that's important for me to check that out as opposed to something like here, which is a P2025, which I have the example to see if I want to see a better one. So we can like actually compare if we want. So this one is a relatively faster one because it took 250 milliseconds, right? And here, the really bad one, P98, is this one. But the interesting thing is that the problem is always in the client, and it's never elsewhere. So that's where we got to fix things. But this time series view really helps you understand various, like, what's the curve of your latency graph, and see which ones, where you need to put your effort, what's the most important stuff to see. If you had errors, it would be highlighted here as well, and you could just fix that. So that's all this data that we're showing here, all this analysis has come in through, because the OpenTracing instrumentation hooked up with the Lightstep tracer gave me all this. Now, as I mentioned, vendor neutrality is really important, right? If any company is going to invest their time and energy into getting these, getting OpenTracing instrumented, they want to know that they have options. So as Brian had mentioned, we have a clone app, which looks very similar. It looks the same. Similar is not the right word. And I'm going to just like click around here a little bit to show the same thing in Jaeger. So I'm going to add an album, just say Priyanka sings. Priyanka, release here right now. Genre, conferences. And I'm going to say OK. And just click around a little to like, make things happen. And just as a safety, I'll do one more. Doesn't sing. Artist, not Priyanka. Release year 2005. 9, genre, conferences. And I hit OK. So now I should have a few traces. And I'll go into the Jaeger UI. I'm just going to refresh for good measure. And I've chosen the Spring Music service type. And I'm going to hit Find Traces. And I see, as Brian had shown you, there's like lots of dots here, right, which are showing you various activity. And I click this one, and I see the trace. Now, you'll notice here there's only two processes, not 3 like the previous one. And that's because in this specific tracer, Jaeger, it only looks at the backend stuff. It doesn't look at client information. So some tracers do it, some tracers don't. It's not OpenTracing's decision. OpenTracing is already instrumented. It's like tracer can decide whether or not they want to do it. And just like we had in the Lightstep view, you can see all the information that's already we got for free because JDBI and Web Servlet are already instrumented. So as you can see, you can look, same application, different tracing systems, and all great, right? All right. So that was the demo part. Let's see. I hope this was helpful in illuminating kind of, tracing in action. Of course, this is a much simpler system than what you're used to, so you'll probably have like tons of spans. I've seen some million span traces. It's nuts. And that's where that yellow line for the critical path is your lifesaver. All right, these are just like backup slides I had to make sure. And this is an example of a slightly bigger trace, which is more like normal of what would look like. In fact, even this is small. It'll be like just long. But the critical path, as you can see, really helps because I know I don't need to worry about these. I should focus on things that have this. And yeah, that was just save. OK, So that was just a little bit about OpenTracing, about distributed tracing, and how you can get started. If you want to dig deeper, please go in. The Spring app with Jaeger is available on that URL. It's music tracing Jaeger, so remember that. And you can go to the Jaeger UI URL to actually see the traces and play around. So this is available to you. Thank you to Microsoft for giving those links to me. If you want to learn more about OpenTracing, we have a lot of, we're a very active community. So we talk a lot on Gitter. We have a medium where we post, I post a monthly newsletter with all the happenings and all the cool new instrumentations. The coolest thing about working on OpenTracing is, as I said, every day the scope expands, and every month I report on it, and it's really fun. You can follow us, email us, whatever you need. The instrumentations, there's lots in the world, but some specific ones are approved and managed by us, and they're in OpenTracing Contrib. The three specifically used today here are Spring Boot, Web Servlet, and JDBI. I listed those just for convenience. And if you want to talk to me, have any questions, you can tweet me at Prityanka, or that's my handle pretty much everywhere. So yeah, that's a little bit about tracing and the resources. And Brian, do you want to?
Oh yeah, so yeah, we just got a little bit more. Just I'm on bbenz at Twitter and GitHub. If you look at the GitHub, I've got a script basically that describes all the details that I had to do to get that Spring Music app running with Lightstep on Wildfly. Also, there's a little bit about some of the settings I had to change in the application. There's a couple of things I had to change that would work if you just run it in Java versus running on Wildfly. It's a little more strict because it's a J2EE server. And things like setting up memory and stuff like that. That's all in the script in the repo. So if you go to my GitHub repo, bbenz, BBENZ, also my Twitter, and you can see all the different steps you have to go through to set this up on Azure on a VM. And actually, probably be any Ubuntu VM. You have to set it up that way. So that's about it. So thanks for coming. I don't think we have time for questions. I don't know if there's another session. I think this might be the last session of the day. So thank you for coming, by the way. But anyone have any questions for now, real quick? Okay. All right. Thanks, guys.